So I'm going to go ahead and start this. Did we do while loops last time? Okay, so we've done while loops. Did we do variables last time? Okay, so I've touched on both of those. We're going to use a couple of variable examples starting today. So we're going to, in your task main, make sure you've got your test bed template set up. We're going to identify, we're going to put int, and we're going to write the letter biggest. We're going to make a variable, and we're going to use this variable to basically identify sensor functions. Can y'all see that? Do I need to zoom in a little bit? I think I need to zoom in a little bit so that you guys can actually see that on the board. So go ahead and type in int biggest. There we go. That should work out a little bit better for us. And then we're going to make a while statement. So put in while true, because we do not want this one to end. And on the inside, start a curly brace. And then right at the very beginning, we're going to put biggest equals or is assigned to 0, and then put a semicolon. So right whenever you enter this loop, the first thing that it's going to do is it's going to say, okay, well, this thing that you made biggest, that's equal to 0. And it assigns that value. After that, we're going to put in another while loop. So we're going to put a while loop in a while loop. Okay, now if you make both of these while true, it will never leave the second one. So we're actually going to have to put in a condition here. So I'm going to put in a condition that can end, and we're going to call it while sensor value of the bump switch, oops, capital V, is equal 0. So this is actually checking to see if it is equal. Okay. And then we're going to put in another curly bracket. And then we're going to do if sensor value of the potentiometer is greater than biggest. And then we're going to open a curly brace, and we're going to type in biggest is assigned to sensor value and then potentiometer. And then we'll talk about and we'll discuss what this actually means, because I know this is a lot of code to write at once. And I'll be really honest with y'all, I'm cheating. Over on the left side of my screen, I have the code over here. So don't think that I'm being some like uber mega genius by like, oh my gosh, look at this guy, he's just writing code like crazy. So normally, if you're actually writing this out to do something, there's going to be a lot of trying to feel your way through this kind of stuff. I can write it, it just would take me a lot longer. So in order to actually kind of like talk this stuff through, it's best to have some just code on hand that actually works out. This should work. So once you get it set up like that, hit the little magic wand button at the top that says fix formatting, and it should look like roughly this. Check and make sure that all of your curly brackets have a starting one and an in one. So if I'm looking at that if statement at the very beginning, or at the in the middle, kind of like in the sandwich part, there's a beginning to the curly brace and then there's an end to the curly brace. And then the while structure on the inside, while the sensor value, there's a beginning curly brace and an end curly brace. The while true has a beginning and an end, and the task main at the very top has a beginning curly brace, and then at the very bottom it has a curly brace as well. So that way you at least know that there's not going to be any errors. If you think that it looks good, hit compile, see if it actually comes up with any errors. I haven't hit compile yet, so I don't really know if this is going to work or not. Mine does come up with one. That's because I can't capitalize the V on sensor value. There we go. Let's fix that. Okay, I had a warning on mine. If you fix that one, it should be okay. We don't have any values for what? Right. So this isn't actually going to start motors. So what's going to happen is the computer inside is going to tell it to do something. So whenever this happens, while you're actually pressing the bump switch, so while the bump switch is open, then what you're going to do is if the potentiometer has a value that is great, if the sensor value, yeah, if the sensor value of the potentiometer has a value that's greater than this variable that says biggest, then it's going to become that new number. So what this variable is going to be doing in this situation is this is going to be storing the maximum possible value for us in the potentiometer. So in this case, we're not actually triggering the motor to do something or the light to do something. What we're doing is we're triggering a value inside the computer to be stored in case we need to use it for later. So whenever y'all hit start, make sure that your potentiometer is all the way to the left. So I'm going to take this. I tried to plug mine in as well. I stole a test bed from fourth period. So I'm going to hit download the program or download the robot. Let it do its upload thing. Clickety, clickety, clickety. And we should have this debug window. And if this works right, although I've had a little bit of issues with this in the past, um, down here at the bottom, there should be global variables and local variables in little tabs. See where my mouse is? It's a little bit down here. So since I've got the screen zoomed in for y'all on the board, it's down here where it says variable. You'll have to type on the one that says global variable. And it should say biggest and the value should be 0. Whenever you hit start, the program will turn on, but you're not going to get any motors that happen. Yeah, you're going to get a couple of errors going there. So try. Yes, you have 6 red X's. Welcome to the joys of programming. Did you hey, wait a minute. Did you load up the test bed file that actually has all the setup stuff on it? So, hi. No, 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 no. Here's how you don't write this again. Highlight all of the text like this. Just click and drag with your mouse. You do not have to write all this again. If you've written it once, don't do it again. Click and highlight with your mouse and get all that text. There you go. Right click. Yeah, you got it copied. Okay. Then whenever you open it up into a different file, so just hit open file and you should be able to find your test bed. Hit open and then paste it in there. Yeah. Get rid of all that stuff. And then, no, 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 not the, so go down to, yeah, and then that's it. All right, now you still need a couple of curly braces before you're done. Yes, you're getting there. You need one more at the bottom, and then, whoa, 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 and then one more on top of that. There you go. Hit fix formatting so you can actually see it. There you go. That looks decent. Compile that, see if it explodes. Call it a testbed 3. All right. Now, for everybody, when you change the value of the potentiometer, there should be a variable value that changes along with it, and you should get a new value that stays as the biggest. Okay, which window is that window? You hit download to robot, so you actually have to get it to download without exploding. Well, it says no communication is available. Yeah, you have to actually have it uploaded. You have to have, in order to get that window, you have to actually have a test bed hooked up to your computer. That's why I stole one from fourth period, so I could actually get it to show up. I'm going to move this, I'm going to attempt to move this down a little bit. I'm not doing a very good job. So, there we go. So y'all should have this thing down here in the bottom left that says variable biggest, and then this value should stay on the largest number that you have whenever you move it. So you don't have that at all? So where it says variable biggest, okay. Then let's do this then. Okay. You don't none of this shows up at all in the bottom where it says biggest and then value at all? Okay. So then let's do this. Up here at the top where it says robot, click on that button that says robot and go to debugger windows and make sure that you have the thing that says global variables and local variables checked. If those aren't checked, then these things down here aren't going to show up. If it doesn't let you actually click on it, go ahead and click stop on the program debug and then go back into it. Has it grayed out? What kind of grayed out are we talking about? Right. It won't let you click debugger windows unless you have download to robot on. So go ahead and hit download to robot. Okay. Does it actually show up down there? Hit start. Hmm. This might get a little interesting for us then, huh? Won't it? Yeah, you should have global variables, and it should actually show up down in the bottom. The fact that it's not is a little disturbing. Well, looks like this is going to be a technical difficulties. Please stand by moment while we try to get everything going. Um, and you hit download a robot and it actually works. Okay. And yeah, it can see the sensors too, and you can actually see the potentiometer value changing. Okay. Um, that's reasonable. Okay, well, what it's supposed to do is it's supposed to give you that output value down in the global variables. And the main reason why they're wanting us to do this is so that we can uh, see that you can actually store a variable inside or store a number inside a variable in case you ever need to use it for later. So there can be situations where you're trying to either find like the maximum value or the minimum value. And this is one of the ways that you guys can do this using variables. So you don't just have to use a variable to move a motor or something like that. You can actually keep it to store values if those values are important to us as well. This is just one of those ways to do that. Okay? So I'm not too terribly worried that it doesn't work um, because whenever it comes down to it, a lot of times, unless you're getting into some really fancy programming, you probably won't need to do this. But it is there and it is available to you in order to be able to do. Okay, and this is also, keep in mind, this is using a while loop, and this while loop, is um, the first one is while true, so this just keeps going on and on and on. So while you're in here, it will actually record the sensor value of your potentiometer if your bump switch is open. If your bump switch is closed, if the bump switch sensor value equals zero or is equal to zero, I'm sorry, closed or whenever you press on it is equal to 1, if you press on that, then it won't record that number anymore. And it'll go out of that while loop. And whenever you press that button, since it goes out of the while loop, it will go back into the previous one. And whenever that happens, it will change that value to 0. So I'm going to go ahead and I'm going to hit start again. I'm going to change the value of my potentiometer, and you can see how whenever I twist on it, the value increases, but whenever I twist it to the left, it doesn't go back down. So what it's doing is it's recording that top value, and if they've set up this test bed right, whenever I press the bump switch, it goes back to 0 or 1, whatever that lowest number is. So I can record the highest value that gets turned on this potentiometer, and then whenever I hit the button, it resets. Okay, let's see. Successful use cases for this. Let's see. Why would we actually need something to show up? That's a good question. Why would we need to record the biggest value and then need to be able to reset it? Let's see. What kind of machinery would be related to trying to find the biggest value of something or the smallest value of something? Hey, what? Dyno Machine? What's that? Okay, what's it? And you need it to reset. Oh wait, doesn't that find like the maximum horsepower? So then after it's done, after you find that maximum horsepower, you're gonna need to reset it, right? It's not just gonna be set at that number and then that's it. So yeah, that's actually a really good example of that. Yeah, a dyno machine, which is a dynometer or something like that. It's got a weird name to it, but it's a computerized machine that'll let you find the horsepower of a car. That's totally true. Um, the multimeters, scales are a good example. Yeah, the digital scales, whenever you press on the digital scale, it will tell you what the maximum number that you found is, and then after you step off of it for a while, it will reset back to zero. That is totally true. That's another one. That's a good one. So if we look, we can actually find some uses for this segment of code that would actually show up. The scale was a good one. Dyno was a good one. Any other ones? Okay. Let's make our life a little bit more interesting. I'm going to teach you guys how to write a function, and it's actually not too bad. Okay, I'm going to hit stop. I'm going to close this out, and I'm going to go ahead and I'm going to erase what I've got in here. If you want to save this segment of code, just hit File and Save As, and whenever you hit File and Save As, it will save that segment of code. You don't have to rewrite it. But if you don't want it, just go bloop, and it goes away. Go ahead and whenever you hit save as, um, call it here. I'll go back. So if you want to save it, hit File, Save As, and then call it instead of testbed template, call it maximum value because that's what this segment of code actually does. And then you'll have it there. Okay. And then I'm going to go ahead and I'm going to open my testbed back up again. And I'm going to go back to task main. So I'm going to erase everything. Bloop, like that. So I should have this little tab up here that says testbed template 2, and then inside the little brackets it should just say task main. We're going to write a function, okay? Um, this first thing where it says task main, this is the main function. So whenever you run a program, the default function that it does first is going to be task main. It always does this section first. But just because it does that one first doesn't mean you can't put other functions inside of it as well. And what a function is it's basically a block of code that you can just call back and reference multiple times. So if you've got something that it does over and over and over and over again, you don't want to handwrite that code over and over and over and over again. What you do is you write a function and then you just use that function to put it in that place and you don't have to write that code out. Okay? Does that kind of make sense? Or am I talking Greek? It is a whole different language. You're right. You're right. It is a whole different language. Here, I'll do this for you. Okay. Um, so we're going to um, write out this thing that says task main, and we're going to put in here while true, and then we're going to say I'm going to put in here if sensor value of the bump switch equal 1, turn LED on. I think I called mine green LED. you might want to make sure that you actually call the right LED function. It's going to be up here at the digital port 12. So I called mine green LED. You're going to type in whatever you've got there. So turn LED on, green LED, and then I'm going to close that curly bracket, and then else turn LED off, green LED. Yeah, if y'all just copied my test bed, y'all probably have it called green LED, even if your LED is not green on the test bed. It doesn't matter. There's not a difference in the colors. I'm gonna hit fix formatting, make sure that everything looks okay. I think this is good. I'm gonna hit compile program. Okay, so try to get that going. That looks like that. Task main, and then while true, if the sensor value is pressed, it's going to turn that light on. If it's not pressed, it's going to turn the LED off. So turn LED on, else turn LED off. Okay. Then whenever you get it that way, go ahead and hit download to robot. And this should be a really simple program using a while loop that never ends. Whenever you start it, if you push the button should turn the LED on, and when you let go of the button, it should turn the LED off. Perfect for Morse code. Okay, does that make sense? Everybody's work? Everybody sees that it works? Okay, we're going to make our life a little bit trickier. Okay, what if I didn't really want to put this all right here? What if I wanted to just make that a function? So I'm going to show you how to make this a function. The first thing that we need to do is we're going to have to declare that we've actually got a function to start with. And so up here, I'm going to type in my function. I'm going to call it void LED control. And then everybody's like, void? What the heck is going on here? Um, Whenever you write a function, the thing that you put in front gives it what's called a return value. So you can make functions, and whenever the function completes, it will return a value, and that value can be used in other parts of the functions. Okay. Here's the thing about functions: they don't really listen to each other. So if you've got one function doing something, unless you tell it to return a value, it's not really going to listen to the stuff that goes on in task main. So functions kind of mind their own business. Functions are like the neighbors next to each other that don't really pay attention to anybody's business, and they just kind of like let things go. So if something crazy happens in task main, the LED control function will have no clue what's going on. If something crazy happens in LED control, then task main is going to have no clue what's going on. So we're actually going to have to write this function out. So I'm going to write this function down on the bottom here. So I'm going to type in void LED control, but I'm not going to put a semicolon there because I'm not ending this. I'm going to start a curly brace. And I'm going to say, all right, well, this is what my function is going to look like. It's going to look like this thing. So I'm just going to cut this part out and put it down here because I'm lazy and I don't want to retype it. Okay? And then a lot of people are like, well, wait a minute. If I. Okay. All right. So we're here, right? Like, we need a moment. Okay. Ooh, what we got going here? New phone. Who dis? Still need a second? Well, Pretty much, yeah. All right. Uh-huh. Okay, so the deal is that right now we have turn LED on, green LED. I think the O needs to be capitalized on LED on, and I think that will fix that problem. So if you get rid of that and then do capital O, try compile on that and see if it actually works. That made it worse. Okay. Well, that's all right. That's all right. Let's see here. We have yeah, right now the function doesn't really do anything yet. So your what's it say down there? Undefined procedure, turn LED on. Hey, make sure when it go up to robot and go to platform type and make sure that you've got natural language selected for PLTW. Now hit, there you go. That's going to fix a lot of it. That bottom X, don't worry about that yet because we're not done yet. Because obviously that bottom one, if you compile it where it says void LED control, that's going to give you a red X because there's an open curly brace and there's not an end to a curly brace. So that is definitely going to throw an error whenever we do it. I was just giving you all a little bit of time to catch up. So this spot right here, the whole point of doing a function is to take easy code that's repetitive, like this, where it's if something happens, turn it on. If not, turn it off. This is a specific repeatable task that we could use for other things as well too. So what I'm going to do is I'm just going to take this snippet of code from the if statement to the end of the curly bracket on the else statement, and we're going to just move it down into this function called LED control. So since we're lazy, y'all are going to have to get real good at copying and cutting and pasting because that's like 90% of what programmers do anyway. They just take code that's already been written and they just cut and paste it everywhere. They do a little bit of hand typing, but it's usually just like modifying code that already exists. So we're going to take this segment from here to here, and we're going to right click and we're going to click cut. And we're going to put it in to we're going to put it in to void LED control. So everywhere when it starts at if, and then what is that? 1, 2, 3, 4, 5, 6, 7 lines down. Go ahead and highlight that 7 lines down where it goes else, turn LED off, and then close curly bracket. Cut and paste that down into the bottom one. Okay. And then back up here in the while true, instead of actually writing all that code in, we're going to say, hey, we've already got a function for that. We're going to call it LED control. So I'm going to just type in LED control and then open parentheses, close parentheses, semicolon. Uh-oh. Well, yeah, it looks like I'm doing the same thing. I've got X's all over the place. All right. Well, let's see what I just did. Let's see. Everything exploded. Yeah, and the funny thing is, this is exactly what they're telling you to do on this one. Hey, did I put task main in here? Yeah, there's task main. Okay. Apparently, I'm not either. So, well, one, it's perfect. Yeah. Hey, whenever you guys actually do programming, you're gonna need to understand that errors get thrown up a lot of the time. Right? Yeah, like Python's just kind of like whatever. Here's an error. What's wrong with it? At least with this robot C stuff, you can look down here at the bottom and it tells you a bunch of stuff. Even if the stuff sometimes doesn't really make any sense. Um, let's see. I think I might know the problem. So first thing I need to do is this LED control. I need to have an open and close parentheses right there. And that fixed everything. Literally all of those X's got fixed by throwing in those open and close parentheses. So just remember, y'all, computers are really stupid. So if it tries to run something through, a function itself, whenever you write out a function, you have to put that open and close parentheses there because it's expecting you to put in parameters for a value there. And that goes into a lot of computer science stuff that I'm not going to get into. If you want to learn how to do functions a lot better than this, just knowing how to be dangerous stuff, take a computer science course and they'll teach you how to put parameters in those functions as well too. But for us as engineers that just, need to know enough stuff to be dangerous, make sure you've got that open and close parentheses in there. And when you put in that open and close parentheses, you should be okay. Yeah. I don't know. Let's see what's broken with it. We'll find out. There is one. I see LED control, open, close. It says undefined procedure, global subroutine assumed. Okay, so at the very, very top, right above task main, you need to type in void LED control, and then open parentheses, close parentheses, and then semicolon. And I think that will fix it because you didn't declare your function at the very beginning. So for robot C, you have to tell it that there's a function that's there, or else it's not really going to know that it's a function. It's going to be like, hey, what's this? I don't really know what's going on. Let's see. Yeah, it shouldn't because it should do if it's on. Hey, wait, no, because do we have it in a, well, we've got it in a while loop, so it should turn off. So it should, whenever you press it, it should turn on. Yeah, because if you have the switch equal to 1, it should turn on, and then else it should turn off. So we should have it set up to where whenever you press it, it will light up, and then whenever you let go of it, it should not light up. So what we're gonna do here is we're just gonna keep going through the code and we're gonna test this out. So I figure if we can get this stuff working, we'll be good to go. But I'm gonna go ahead and stop the recording there for the poor POE kids who are digital. Good luck, guys. I'll talk at y'all later.